class. Dr. Yeager here, and welcome to our first little mini lecture. This lecture goes over Chapter 8 in your blue book and covers part of what's talked about in your online book and the Planet Earth section, as well as the plate tectonics section. It's a fairly short reading and largely review material to sort of get us into the class. So a lot of people have never taken a geography class before, and one of the things that we have to start with in a geography class is the assumption that a lot of folks don't really know what geographers do or what you study in a geography class. A lot of people think it's mainly just memorizing trivia about places and state capitals and things like that. And I can assure you we won't be memorizing any state capitals in here. Unfortunately, that misconception about geography comes from, I guess, the fact that geography isn't taught very well at the high school level and at the junior high level. So you end up with a lot of people that don't really know what geography is. Well, that's what we're here to do today, to sort of reconcile that. Well, geography is the study of the uneven distribution of things and how that uneven distribution of things impacts people who use them or people whose lives are impacted by them. Now, that's a nice broad definition, if a broad definition ever existed. And that's kind of by design, because geography by its very nature is a very much broad field of study. One of the things you're going to realize in this class and going forward is that everything has an uneven distribution. Now, when I say an uneven distribution, think about the way things are distributed on the planet of the Earth, okay? And I'm just going to say something at random, and I want you to think, okay, is that thing randomly or evenly distributed, meaning there's as much of it in California as there is in India, or there's as much of it in Australia as there is in Antarctica? Or is it unevenly distributed, meaning there's more of it here than there is over there? Okay, so and I'm just going to start spitting out things. Cornfields. Are cornfields evenly distributed? No, of course not. There's lots of cornfields in Iowa, and there are very few cornfields in the Sahara Desert. Okay, they're not evenly distributed. There's more in some places than other places. Rice fields. Okay, again, there's more of it in some places than there is in other places. What other kinds of things? Palm trees. There are lots of palm trees in California. There are lots of palm trees in Las Vegas. There are lots of palm trees in some places, but there are no palm trees in Greenland. There are no palm trees in Scandinavia, right? Palm trees require a certain type of climate, and so they don't exist in certain places. Snowmen. Right, there are more snowmen in places where there are snow, obviously. So I think you're starting to get the idea that most physical things are not evenly distributed. Mountains, volcanoes, deserts, all these things are not evenly distributed, and there are reasons why they are where they are. If they were evenly or randomly distributed, that could mean they could just be anywhere. A random distribution means there's just as much likelihood of a desert being in Brazil than there is of one being in, the middle of Australia, right? So a random distribution means things just are where they are for no reason. A systematic distribution means that there's a reason why things are where they are, okay? And of course, as we've gone through, cornfields and rice fields and mountains and things like that, all these things that aren't randomly or evenly distributed, there are a reason why those things are where they are. Deserts are where they are because of certain climatic conditions that cause for very little rain, at least most of the year. And we'll talk about climate at a different point in the semester. But if we look at this map here, here's a desert right here, deserts right here, desert right here, desert right here, desert right here, desert right here. And if we go around the world and look at latitude and longitude, we will see that at about 30 to 40 degrees north and south of the equator, that's where all the deserts are. The climatic conditions at those places tend to be conducive for the development of deserts. That's a systematic distribution, meaning there are conditions that allow for those things to happen there. Mountain ranges, right? If we look at where the mountain ranges are on this map, or we look at where the volcanic mountain ranges are on this map, so we can see those with the little purple triangles. They're not spread all over the place, right? There are no volcanoes in pretty much all of northern Asia. There are pretty much no volcanoes in much of North America. They're all sort of clustered together. And where are they clustered together? Well, they're clustered together where you have what's called a convergent plate boundary. We'll learn about convergent plate boundaries here really soon. You have to have a convergent plate boundary in most places to get the development of volcanic mountains. They're not just randomly distributed. They're put in place where you have a certain condition, like a convergent plate boundary. Okay? Geographers study those systematic distributions and why those systematic distributions exist. So in physical geography, we would study, why are those types of volcanoes where they are? What are the reasons for which? And we would also study, what does that mean for people who live in those places? What does that mean for agriculture in those places? What does that mean for maybe climate in those places? We focus on the physical stuff. Geographers also study human things too. So we might look at a map of wealth around the world, and wealth obviously isn't equally distributed. There's a lot of wealth here, and a lot of wealth here, and a lot of wealth here, and there's not nearly as much wealth here, or here, or here. Why is that? Well, there are reasons for that too. We won't be studying things like that in this class, but if you're interested in those things, that's one of the great things about geography is you can study lots and lots of different things. But nothing, and I mean nothing, that is naturally occurring has a random distribution on the planet. Zilch, zero. You can't come up with something that does. And even things that would seem random, like the amount of oxygen in the atmosphere or the amount of carbon dioxide in the atmosphere, it would seem like those would be the same everywhere, but there are variations on even those things, okay? So everything has a systematic distribution. In geography, that's what we are going to study, okay? So as we kick off our semester here, we're basically going to break it into two main topic areas. The first part of the semester, sort of like the first little over a week, we're going to learn about the Earth, how things are, how landforms are created, the internal structure of the Earth, volcanoes, earthquakes, how streams affect the land, weathering, erosion and deposition, things like that. Second half of the semester, we'll learn about weather and climate. So if we're going to learn about the Earth, let's start at the start and understand the different layers of the Earth. So we've all learned this before. This is all a review. It may be a review from a long time ago, but it's definitely a review. If we think about the Earth, we can think about it in two different ways. We can classify the Earth and its layers by their chemical composition, meaning what they are made up of, or we can classify the Earth based on their physical properties, meaning is it hard, is it soft, is it liquid, is it solid, that sort of a thing. If we think about the Earth based on its chemical properties, there are three layers. Okay? And those three layers are the crust, the mantle, and the core. Excuse me. The crust is the outermost layer, and there are two types of crust. There are continental crust, which is the crust that makes up the continents, as the name implies, and there's oceanic crust, which is the crust that is at the bottom of the ocean. The crust that makes up the continents is largely granite, and the crust that makes up the oceans is called basalt. So it's called basaltic rock. In general, basaltic rocks are more dense than granite rocks. Granite rocks are going to be less dense, and so as such, granite or continental crust is going to have a tendency to float up or sit up higher on top of the mantle than that basaltic oceanic crust, which is going to sit down on the mantle. And that's why the continents sit up higher and the oceans sit down lower and are filled up with water. So the crust is the outermost layer. The mantle is the layer underneath the crust if we're looking at the Earth in terms of its chemical composition. And the mantle is pretty much made up of silicate materials or silicate minerals. Underneath the mantle is the core, and the core is made up of iron and sulfur, nickel, and some other things. So if we look at the Earth by its chemical composition, we have the crust, the mantle, and the core. Okay, probably of a little more value for us is to look at the Earth in terms of its physical properties. When we do that, we are looking at the Earth in we're looking at the lithosphere at the outermost layer. It's sort of the equivalent of the crust, and the lithosphere is solid. Okay, obviously we're walking around on the lithosphere every day. It's solid. Underneath the lithosphere is a layer of the mantle that we call the asthenosphere, and the asthenosphere, in terms of its physical properties, is neither solid nor liquid. It's kind of in between. And if you've ever taken a physics class, you will know that the term used to describe something that is neither solid nor liquid but has properties of both is referred to as plastic. And so this asthenosphere is what we call a plasticky layer. Now, that doesn't mean it's plastic like your Quick Trip cup or your cell phone case or something like that. That means it's malleable, it's bendable. We can squish it down, we can stretch it. And that's important because as the lithosphere sits on top of it, remember we said how the continents were made up of granite and they weren't as dense as the basaltic oceanic crust? Well, because the asthenosphere is malleable or compressible, that means that dense oceanic crust is going to push down into the asthenosphere and actually compress it, and that's why the oceanic crust sits down lower than the continental crust that sort of floats up on top. Okay, the asthenosphere is compressible. I sort of analogize it to sort of a memory foam mattress, how you can sort of squish it and leave your handprints in it if you exert pressure downwards on it, and if you remove your hands, the pressure goes away and it comes back up. Underneath the asthenosphere is something called the mesosphere. The mesosphere is part of the mantle, and it is solid. So we started at the lithosphere, we're solid. The asthenosphere is plastic. The mesosphere is solid. And then down into the core, the outer part of the core is liquid, and the inner part of the core is solid. Okay, so we can think about the Earth in either of these two ways, and primarily in this class we will, since we're really mainly interested in the surface, we'll sort of focus on what's going on kind of up here with the lithosphere and the asthenosphere, or the crust in the top part of the mantle. But we do want to understand how these things how things are organized, at least down within the Earth. Okay, I'm going to stop there, and we will pick up in our next